Welcome to everyone. On previous class we have discussed about the character tables, and we have discussed that how to draw character tables. With that we have some rules. We see, and we also see some postulates that are given by great orthogonality theorems, GOT. So I will just recap that what I have discussed previous class. So we have discussed how to draw the character tables. So character tables we are drawing. Here was the part 1, here we do say that here part 2, and here is 3, and here you say the 4. After that here we have 5, and here we have 6. So this is, you say that for 2 rows and 4 columns, this is row 1, and this is row 2, and this is column 1, and this is column 2, and this is column 3, and this is column 4. And we say that here that on file notations of point group will be written group, and here the symmetry elements will be written symmetry elements, and here that Malkin notations of irreducible representations. Here we will write the characters of irreducible representations, and here we write that transformation properties of rotational and translational. Then you write that quadratic equations. Okay, so that we have discussed in previous class, and we say that the 4 rules we have we say that GOT, great orthogonality theorems, that gives that 4 postulates. It gives that 4 postulates. What are the 4 postulates? That first it says that first postulate says number of classes in a group equal to number of Malkin notations or Malkin symbols of irreducible representations in group. Irreducible representation. IR means irreducible representation, that already discussed. And second postulate, what he says that the summation of square of irreducible representations of symmetry of identity elements is equal to order of the group, that is represented by H. And third postulate, what is H? Third postulate says that the summation of square of any two irreducible representations any two irreducible representations, here also irreducible representations is equal to order of the group, Okay, here that identity means here that the dimensions is talking about of dimensions. The square, the summation of square of irreducible representations of any identity element is equal to the order of the groups. And for postulates, he says that the product of any two irreducible representations are orthogonal to each other. Orthogonal to each other means if you do the product, if you do the multiplications of representations of any two irreducible characters, then we will get the 0. Okay, this we have discussed. With that, so if you use these four formulas, then let's say for if you take about of water, this is that water, so here we will write that sample notations of point group. So point group for water is C2B, and you will write the symmetry elements, so E, C2Y, sigma YZ and sigma XY. If our axes are like this, X, Y, Z. So remember that this X, Y, Z can be taken anywhere, like if you take this way also, and some persons may take this way, so anyway is fine. Okay, so in which way you will take, like that your this axis will come here. Okay, so first postulate what we say, that number of classes equal to number of irreducible representations. So here you will write that Mulkin symbols, and IR1, IR2, IR3, that is equal to the number of classes. That what say the postulates 1. So here I will draw up to 4, because 4 classes, IR2, IR3 and IR4. This is by first postulate says. Okay, and second postulate what it says, second postulate says that the characters of identity elements is equal to the order of the groups. So the characters of identity elements, this identity elements is equal to the order of the group. So for this C2B, the order will be 2n. So n is here 2, so 2 into 2, that is 4. Okay, so this second postulate, they say that the summation of square of, we can say that the summation of square of character of identity elements, or I can write here because previously we don't know about of that irreducible representation. So we are actually calculating the irreducible representation. So this postulate says that the summation of square of character of symmetry elements, characters of identity elements or operations is equal to order of the groups. Okay, this is equal to order of the group. So here is 4. So after if you add, you should get the 4. So how will add? 1 1 1 1. So if I do 1 1, then also I am getting 4. Also if I can minus 1 1 minus 1, then also I will get 4, because this is the square of this also giving 1, this also going to give 1, this also giving 1, this also giving 4. But another conditions, we know that dimensions never be negative, like height can't be negative, so dimensions can't be negative, so we can't put minus 1. So here only we will put plus 1, that is 1 1 1 and 1, and this, and for IR1, that irreducible representations are always the value of 1. So for IR1, for any groups, that is always give by the 1 1 1. Okay, this one you should not always 1. After that, here for this this and this, we will follow these two rules, the summations of. So here let's say this is A1 E1, this E1, A2 B2 and C2, this is A3 B3 and C3. So for these values, or to get these irreducible representations, we will follow the two postulates, that is postulates 3 and postulates 4. The summation of square of any two irreducible representations is equal to the order of the groups, postulate 3 says, and the product of any two irreducible representations are orthogonal to each other. So if you follow these two rules and apply this here, then we will get this values. Okay, so for this law, postulates 3 and 4. Okay, and for this we follow postulates, which postulate 1, and for getting these values we will follow postulates 2. Okay, and for this, that is always this value. Okay, so if we follow all the postulates, then we will get for C to B, that we already discussed in previous class. E, let's say C to Y, sigma yz, sigma xy, then this IR1, IR2, IR3. Why I am writing that? After following the postulates. Okay, 1 postulates and this point. After following the power postulate and these points, I will get this values. This one I'm after following the postulates 3 and 4, I am writing these things. Okay, so if I write here -1, then 1, here I have to -1, and -1, -1. So this one I am getting after following the postulate 3 and 4, means all postulate following up I get these things. These results I got after following 4 postulates. Okay, now to get these values, now we have these values, this one also you have to represent. So this value, this Malkin notations of irreducible representations, to get this value we have to follow four rules. Now what are the 4 rules? That these 4 rules with respect to this, whatever you get this irreducible representation, these are irreducible representations. These are the irreducible representations of this table, or of this point group, So we have, for getting this value, we have to follow 4 rules which are with respect to this irreducible representation. With respect to this irreducible representations, how we will say this first rule? What he says that identity, that is identity, you can say irreducible representation, irreducible representations with respect to E. Okay, with respect to E means this value with respect to E. What is that? Okay, so what it says that if irreducible representations of E is 1, then we will write A or B, and if irreducible representation of E is 2, then we will write E, and if it is 3, then we will write T. Okay, that's what it says. Like this is for C to B. If I talk about of that C3B, let's say point group C3 first I will draw C3b. So here what E 2C3 and 3 sigma b. So this is the 3 irreducible representations. So following the past postulates, 3 IR1 will come, IR1, IR2 and IR3, because 3 class means 3 irreducible, multi-notation of 3 irreducible representations. I use the postulate 1, and postulate 2 what says that the characters of identity elements is equal to order of the group. So here order will be C3b, that is 2n, and n is 3 here, that is equal to 6. So order I should get 6. So here I will order has to be always 1, because dimension, E means dimensions, and dimensions cannot be negative. So this is 1, 2. So by using postulates 2, the summations of characters of identity elements is equal to order of the group. This is 1 square 1, 1 square 1, 2 square 4. So 4, 1, 5, 6. So I get 6. So this is the using postulate 1, postulate 2, I get this. And this is always 1, 1. For IR1 always 1, 1. That will say these points. By this point I say that for IR1, IR representation are always value of 1. Okay, this I always get. This will be always 1. And next, this using I have to follow postulate 3 and postulate 4. So if I follow the postulate 3 and postulate 4, then I will get here, let's say this is 1, then this is minus 1, then this is 0, this is 1. Okay, by following the postulate 3 and postulate 4, let me just check. 3, this is minus 3, this is 2, okay, this is 2, 1, 3, 0, okay, this is 2, this is 2, this is 2, this is minus. Okay, so by using postulate 2 and postulate 3 and postulate 4, I write this value using postulates 3 and 4. Okay, we check that we already discussed in previous class. So these 4, writing these 4 rules, we have to use this representations. So what are the past rules says that if IR representation of E is 1, then A or B, and if it's 2, then E, if it's 3, then T. So these values, this thing the IR, this values, okay, these values, and here these values. So if these values are that IR representation with respect to E, so with respect to E, what are there? 1, 1, 2 is there. In this case, all are 1, 1, 1, 1. So if 1, then A or B, and if 2, like here 2, then here E will come. Okay, similarly if 3 is there, then T will come. Okay, and this is, let's say that part for 1, A or B. So how will you decide A or B? For that another rules, that if IR representations with respect to principal axis. Okay, so here principal axis is C2. So principal axis, that if it is positive, then that is A, and if it is negative, then that is B. Okay, or I will write, this may be not visible. Okay, so this is rule 1. Let's say this is rule 1 that we already discussed in previous class. I'm just going the quick recap. So rule 1 B, if IR representations with respect to principal axis, that IR representations of principal axis is positive, then that is A, and if it is negative, then this is going to be B. Okay, so here see, this is the Cy. So with respect to this, positive or negative, both are positive. First case, this is 1, then A or B. Okay, so this is A or B. So here A or B will come, here A or B will come, here A or B will come, here A or B will come. Similarly here, if 1 then A or B, A or B. If 2 is, then that is E. Okay, this is that I follow the rule 1A I follow. Okay, after following the rule A2, that if the principal axis is positive, then A, negative is then B. Okay, so here the principal axis here positive, then this will be A. This is also positive, then this is A. Here negative, so this will be B. Okay, so for this case also, here principal axis is positive. For this is the principal axis, so positive, so this will be A. And for 2, that is only E, so no need of principal axis. Okay, these are the things. So after following rule 1, and next is rule 2. Rule 2, what says rule 2? It says that irreducible representations with respect to subsidiary axis, and if subsidiary absent, subsidiary axis, then molecular plane will be looked. Molecular plane. Okay, so what is that? Irreducible representations of subsidiary axis, let's say any NC2 or let's say any CN, that is not principal axis, subsidiary. If it is positive, then 1, and if it is negative, then it is 2. Or if subsidiary axis, CN is not principal axis. Okay, this is not principal axis, but this is subsidiary axis. If subsidiary axis absent, then molecular plane. So irreducible representations of molecular plane is positive, then 1, and if negative, then 2. Okay, this is the rule 2. So looks here this is the molecular plane, this is the axis X, Y and Z, then the XY is the molecular plane for water, cutting XY directions. So here this X and Y, here it is positive, then this is 1, and here this is negative, then this will become 2. Here this is negative, then it's become 2. Here it is positive, then it become 1. Okay, similarly here subsidiary axis is absent, with that molecular plane is also absent. So molecular plane is also absent because ammonia like structure. So this is the not a planar, so molecular plane is also absent and subsidiary axis also absent. Then we will go for any plane. So this is any plane we will go. If both are absent, then go for any plane. Okay, so here this is positive, then 1, this is negative, then this is 2. Okay, this is the rule 2 says. And rule 3, that if sigma h is present, then irreducible representations with respect to I, if I is there, then I say irreducible representations of I is, let's say, positive, then we will do G, and if it is negative then we will go for U. Okay, and like rule for this, if irreducible representations with respect to sigma h. So irreducible representations of sigma h is positive, then we will go for uh, these symbols, and if it's up negative then we will go for both, means these symbols. Okay, so this here, this sigma h and I is not there for C3b and for C2b, so here we will not use. Like if we have that C2h like point groups, then we have that E, we have here C2, I, we have sigma h, we have for these molecules, and we have that IR1, IR2, IR3 and IR4. So for this 1 1 1 1 1 1 1. Okay, so here 1 minus 1, 1, this is 1 1 minus 1, here minus 1 and 1. So here if you do that, then this is E, so all are 1 1, so all will be A or B. So here this is 1, so this is A, and this is 1, so this is again A, this is minus, so here B, this is minus, there is B. Okay, and now we will go for subsidiary axis, or if subsidiary axis is absent then we will go for any molecular plane. So molecular plane, here is sigma h is there, so sigma h, so if it is 1 then this is 1, minus, then this is 2, then it is minus 2, and this is 1. Okay, up to that I, so if I is there positive, then 1, if I is positive then this value, I is positive value, right, this one. If negative then double dash, and if positive then 1, negative then dash. Like this we have to do. Sorry. This is for A, this is A because of this and this A, and this is A, this is here A, 1, this is B, this is B, and since here sigma h is, this is the now sigma, if subsidiary axis and this one we are looking. So here that E is 1, so A, because all are, so A or B will come. Here C2 is 1, so A, here is also 1, so A, positive value, so A, negative, that's why BB. Okay, after that subsidiary axis you have to look, but subsidiary axis is not there. After that we have to look molecular plane, and molecular plane is sigma h, so this will be 1 and this will be 2, and this will be again 2 and this will be 1. Now we will look for I. So if I is there, then positive, then G. I is there, positive, then it will be G, and if it negative, then that will be U, and this is positive, then again G, negative, then again it will be U. Okay, so like this we have to represent. So these are the 4 rules and postulates for drawing the point groups for character tables, and this is the part 1, part 2, part 3, part 4, and for that part 4 and part 5 and part 6, here that Rx or X will comes here also, that will be part 5 and part 6. This is part 5 and part 6, this will not come. So this is say column 1, column 2, column 3, column 4. Okay, so 4 columns. So here Rx and Y, here that that value will comes, that quadratic values, that we will discuss after we discuss about of the irreducible representations. That will be, we will discuss on applications of group theory in next class. Okay, so next we will go through on that the topic is reductions of reducible representations into irreducible representations. This will be reduction of irreducible representations, reductions of reducible representations into irreducible representations. Okay, so for this one formula I will write. Let's say this is the irreducible representations. For this, what I do, order 1 upon h, and this is n, this will be I can be 1, 2, 3, dot dot dot, and here it will be xi, yi, and zi. Okay, so what that xi mean? Here h is order of the group, and xi is that characters of reducible representations, reducible representations, and yi is character of irreducible representations, irreducible representations, and this zi is coefficient of irreducible representations, or coefficient of the group, or that we can say coefficient of symmetry elements, coefficient of the symmetry element in the group. So we will draw that if given any characters of, let's take example of water, then its point group is C2B, and its symmetry elements are E, C2Y, sigma YZ, and sigma XZ. Water is this, and its, let's say we are taking here X, here Y, and Z. Okay, so we will use this formulas to draw that irreducible representations from reducible representations. So it will be given in the questions, given what that point group will be given to you, and we will given E, C2Y, sigma YZ, sigma XZ. This will be given, this is XY, sorry, XY. So this will given, and with that we given that table will given to you. This is A2, B1, B2, and this is given 1, 1, 1, 1, 1, 1, 1, and this will be 1, minus 1, 1, and the group will given 1, 1, minus 1, minus 1, and 1, minus 1, and this will be minus 1, minus 1, and 1. Okay, this will given to you in the questions paper, this will given, and that irreducible representation, the reducible representations of C2B also given, that C2B given E, C2, Y, sigma YZ, sigma XY, and that character reducible representations of 3n coordinates is given to you. This will be how much? 9. We have learned that in previous class, 2 class before, and this will be C2Y, it will be always minus 1, and this will be, this is molecular plane, that is 3, so this will be 3, and this will be 1. So how you do this, that also we have discussed, that how we are do this. Let's say C2B, and for this E, C2Y, sigma YZ, and sigma XY. So what you do, first number of unshifted atoms. So for E, 3 will not shifted. For C2Y, if you do that water molecules which will not shift, so this is water molecules H1, H2, and this is X, Y, and Z. So if I am applying that Y2 here, X is C2Y, then the number of unshifted atoms is 1. This oxygen will not shift, so 1. Okay, and for CYZ, if I apply like this, then only 1 will not shift, and for this molecular plane, so 3 will not shift, so 3. And for that we know characters, that is X, Y, Z basis, the characters we are saying irreducible representation character, or the characters of E. E is always 3, and C2Y is always minus 1, and this is always 1, and this is always 1 for characters. Okay, that we know that. We for C2Y, we know that C and X will reach 2 cos theta plus 1, and for sigma is always 1, and for C2Y or C2, C2Y or C2X, this is always minus 1, that we have already discussed. Okay, so that's we get. So these 3n coordinate systems will get 9, minus 1, 1, and that will be 3. Okay, that's what we get here. Okay, so this much is given to you. Using this, we have to calculate the irreducible representations. So this will given in the questions. This whole things. This also given, and this also given. Okay, so using this, we will calculate the irreducible representations by using this formula. So this formula you have to remember, that 1 upon h equal to xy y into summations of I is to 1 to 3 xi yi and zi. Okay, So how will you use? So we will use this formula to calculate it. So I will write this little bit above. I am writing here reducible representations of 3n c to b e c to y sigma yz and sigma xy. Sigma, this I will write clearly, sigma yz and sigma xy, and this is 9 and this is -1, this is 1, this is 3. Okay, so this is given to you. We have to calculate that. Using this formula we will calculate the irreducible representations. I will calculate. Let's say I use this formula, that is irreducible representations equal to, that is 1 upon h, order of the group, summations of n I, that 1 2 3, that xi yi and zi I will use. Okay, so first I will go for, this is a1, so first I will go for a1. So n of a1 will be, I will use this formula 1 upon h, this is the order of the groups. For c to b, order will be that 2n, and n is here 2, so 2 into 2, that is 4. Order will be 4, so that I will write 1 upon 4. So xi, I am carrying out 4 here. So xi, that is x represent characters of irreducible representations. So characters of irreducible representations. And that is xi and yi. So these are the we discussed that while drawing that character table. These are the irreducible representations. We already discussed that these are the irreducible representations, and these are the reducible representations. These are the reducible representations. Reducible representations. Okay. These are the irreducible representations. Irreducible representations. So now first is xi, that is reducible representations. So reducible representations, for first I will use here e, that is 9. For 1, that is e, first e is there, right? So this e I have to look for, first is character of reducible representation. So reducible representation is 9, so I will put 9. After that I will go for yi. So yi is irreducible representation. For a1 is 1, so I will use 1. After that I will use the coefficient of the symmetry elements. So here coefficient is 1, here coefficient is 1, here coefficient is 1, here coefficient is 1, coefficient 1 1 1 1 coefficient, so that will be 1. Okay, similarly next I come here. After that I will go here. So for this c2y, first I will go for character reducible representations. Character representation is for c2y -1. I will go for -1 into, after that irreducible representation, that is 1. I will go for 1. After that coefficient is 1, because coefficient is 1, so I will put 1. After that I will go for this value cyz. So first that reducible representation sigma yz is 1, I will write 1. After that irreducible representation of this is 1, because first I am looking for this one. I am looking for this one. Okay, 1 into 1 and coefficient is also 1. Okay, after that I will go for this value, and this is the irreducible representation is 3 x by 3, so 3, this is plus, and after that this value is 1 and coefficient is also 1. Okay, so this much if I do, then what I will get, I will write here, this will be 1 upon 4, this will be 9, and this will be minus 1 and minus 1, and here I get 1, and here I get plus 3. Okay, so if I add it, then 1 upon 4, that is 8, that is going to be 12, so that is going to be 3. So in A1 I get 3. So next I will do for next, now I will go for this A2. Okay, previously I do for A1, now I am going for A2. Now and A2. Okay, so same way I apply that order of the groups, that is 4, so 1 upon 4, and I will go for first reducible representation. For this is minus 1, so I will put minus 1 into that irreducible representations of this is 1, of this is 1, something wrong, sorry. First we have to start from, I am doing for this, right? So I have to start first from here. Okay, here I did anything wrong, fine, I start from here, always starts from here. This will I am changing one by one. Okay, always starts from here. Okay, so first is 9 into this value is 1, so 1 and coefficient is 1, sorry. After that I will go for this is minus 1, so I will put minus 1 here into that irreducible representations. This is this case, not here. Okay, I am coming from here. This is 1, so 1 and coefficient is 1. After that again the reducible representations for this, that is 1, I will put 1. After that I will go for this value, this yz is minus 1, so I will put minus 1. After that again I will go for here this value, that is 3. After that here this value, that is minus 1, then minus 1 and coefficient is 1. Here also coefficient is 1, because coefficient is everywhere 1 1 1. Okay, so I direct putting 1 1. So if I do, then what will get, 1 upon 4, this is 9, this is minus 1, this is 9, this is minus 1, this is again minus 1, this is again minus 3. Okay, so if you add all this, then what will get, 1 upon 4, this is 1 upon 4, this is 9, 3 minus 4 minus 5, then you will get 1 upon 4, this is again you will get 4. Okay, and 4 is 1, so Na2 we get 1. Okay, similarly we will next move for, let's say we will move to this one, B1. So again we will do it the same, and B1 order of the group is 4, and we will start from here 9 into the irreducible representations is for, we look now, we are going to look this one, this is 1, So now I will put 1 and coefficient is 1 plus. After that again you will go for here this one, sorry, yes. Now we'll go for next this one, that is -1. So I will put -1. After that irreducible representation, how much for this? -1. So I will put -1. Coefficient is always 1 and that is always, this is 1. So 1 into, and this value is 1. Coefficient is 1 plus, and that value is 3. I will put 3 into, and this value is -1 into 1. So if you add it up, let's, this is got 9, this is 1/4, and this will you get, that is +1, and this will get, again you get +1, and this will get -3. Okay, so if you add it, 1/4, this is 9, 10, 11, 11 minus 3, then 3, 9, that is 9, that is 8, yes, 8. So this is going to give 2. So nv1 we get the 2. Similarly we will go for v2, nv2. So we will go order of the groups and pass that irreducible representation, that is 9, and because this is 9 always, I will start always from here. So 9, and this is 1. So 9, 1, 1, 1, 1, 2, 1. Okay, plus, and that sigma is -1 because this value is -1 always. And this value is -1. So I am putting -1, and this is again -1. So again -1, -1 into 1. That is dimension, coefficient is 1, and that is C2 case. This is 1, sigma yz 1, and this is also -1. Okay, so that is 1, and that is -1, and this is 1, and that is 3, and that is 1, 1 into 1. So if you calculate it, then 1/4, this is 9, this is 1, this is -1, and this is 3. So 9 plus 1, this is -1, this is +3. Okay, so if you add it up, then this is 9, 10, and this is 9, 9, 3, how much? 9, 6, something wrong, 0, 9, 12, 9, 3, 12. Okay, this cancel, and 9, 3, 12, and this is 3. Okay, nb2 is 3. So we get that nb1 is 2, this is 3, and this is 1, and this is 3. So we will check whether it's correct or not. How will check? How I check? Here I will write for all. That first I get that is 3 a1 plus a2. How much I get? 1. So 1 a2 plus b1. How much I get? 2. That is 2 b1 plus b2. How much I get? 3. 3 b2. It is correct or not? How will you check? If correct, then any problem in the calculations. How will you check that you this the value you get? So how will you get that whether it is correct or not? I am doing here. So for C to B, the correct that irreducible representations are, let's see this is this is C2 sigma yz sigma xy, okay. And this is A1 A2, this is B1, this is B2, okay. I have to take the same value, otherwise if I take exchange, then the value will be different. That's why I'm looking this value. The same value I have to put, otherwise that value will get interchanged. Okay, 1, and here 1, I take -1 -1 -1 1 -1, and this is -1 -1 and 1. Okay, so now what I'll do, this A1 how much we get? 3A1, so multiplied here with 3, and V how much we get? Sorry, A2 we get 1, so multiplied by 1, and B1 how much we get? We get, sorry, 2B1 I get, so multiplied here by 2, 2B1, right? So multiplied here by 2, and here 3B2, 3B2. Okay, so if we multiplied it, then this become 3. We multiplied with this, then this become 3, and this also become 3, also become 3, and this also become 3, and this is 1 1 -1 multiplied by 1. Here it become 2, it become -2, it become 2, it become -2, and this all this become 3, this become -3, become -3, this become 2. Now add it, 3 1 3 3 6 3 9, so this is right, 3 3 6 7 8 9. Okay, so if I add it, I should get this value. So whether I'm getting or not, cancel this, I'm getting -1. Okay, because 3 3 cancel, -2 1 -1, this is fine, this is correct. This cancel, and this if I add this, then I will get 1, or then this is also correct. Now I look for this 3 -1, so this is cancel, this is 2, I'm getting here 3. Then something is wrong with this value. Okay, because this is 2 -2 cancel 2, but I should get 3 value. Okay, so something wrong with sigma xy. So we look for sigma xy. Sigma xy, what we put that value, sigma xy, something wrong is there. So we will look for that. -1 -1 -1 and 1. Three -1 and 1, and here I think something -1 1 -1 1 -1, d1 is -1. Okay, -1, that is 1 and -1. D -1, somewhere wrong with here. Let's say this is 9. Okay, this is -1 and -1, so let me check with all. So C2B is, let's say C2 sigma yz sigma xy. So likewise you can check if any wrong, if multiplications get wrong. So this value is 9, this is -1, 1, and this is 3. So here 9, 1 and -1. So you can look by using these values, and this value, right, same value. Anything wrong with B2, so I'm using B2, I'm checking. So 9, 1, -1, 1, 1, -1 and 1, 1, -1, 3, 1. So this is correct. So now I will check for this. And I will check for this. C2B is C2. So this will be 1, 1, 1, and C2B value is so if I multiply this, then I'm getting this or not. So let's say 9, 9, and I'm looking for B1. So 9, 9, okay, 1, 9, 1. Then this is -1, also -1, 1. Okay, this is 1, 1, 1, 1 and 1. Okay, this is 3, 3 minus 1. V1 also fine. V1 also fine, that is equal to 2. Okay, so now we look for A2, maybe here wrong. So C2y C uh, so here if I multiply for A2, and this is 9, 9, 9, then 1, 1, 1, then this is minus 1, 1 and 1. Okay, fine. And this is 1, 1, okay, 1, and this is also minus 1, 1, okay, 3, and this is minus 1, 1. This value is also 1. Is that wrong? Maybe the multiplication wrong here. And minus 1, 8, 8, 1, 9, 9, 3, 12, 3. This value is 1 by 4, 9, 1, 1, minus 1, 9, 9. This is minus 1, minus 1, this is minus 3. This is 9, this is 1, this is 1, minus 3, 9, 10, it is 2. 9, this is 1, this is minus 1, 3, 12, 3. Everything is right, but where is the problem? Here 3 is not coming. Why? So 3, 3, 3, 3, 3, 6, 3, 9, 3, 1, 3 cancel, minus 1, 3, 3 cancel, 2, minus 1, 1, 3, offset. 3, 3, 6, 3 value. Okay, so here I am multiplying by 3, so I have to get by 3. So same values we are getting, then this is correct. Okay, so today after this, similarly for we can calculate for C3P for ammonia. Okay, that we will discuss in next class. Today after this, thank you.